All right, in this video we're going to talk about example 6.2 in the OpenStax textbook, which remember you can download for free using this link. Okay, let's start by reading the example. So some doctors believe that a person can lose 5 pounds on average in a month by reducing his or her fat intake and exercising consistently. Suppose weight loss has a normal distribution. So let X equal the amount of weight loss in pounds by a person in a month. So use standard deviation of 2 pounds. Okay, so we have this notation. X is distributed as a normal distribution. The mean is 5. Standard deviation is 2. Okay, so the first number is always the mean. The second number is the standard deviation. Okay, suppose a person lost 10 pounds in a month. Okay, so that means this is capital X, right? Capital X is the random variable. Little x, which is an observation, is 10 pounds. All right, and first thing we want to do is verify that what is the z-score. So let's go ahead and calculate that over here. Z equals x minus mu divided by sigma. Okay, little x is 10. Mu is 5, and sigma is 2, right? Sigma, the standard deviation, is 2. So remember, you always do what's in the numerator first. So 10 minus 5 is 5, divided by 2, which is 2.5. Good, so we've verified. Z equals 2.5. Okay, so this z-score tells you that 10 is blank standard deviations to the blank of the mean, okay? All right, so let's draw out our distribution. Let's think this through. So here in the center of the distribution, the normal distribution is always the mean. Okay. Then our observation was 10. Up here, 10. Right? And what does Z tell us? Z tells us the number of standard deviations from the mean. Right? So 10 is 2.5 standard deviations, since it's positive, above or to the right of the mean, right? In other words, if you were to say take 5 and add on 2.5 standard deviation, so 2.5 times the standard deviation is 2, right? You get 5 plus 2.5 times 2 is 5, which is 10, right? So we're 2.5 standard deviations above the mean. So let's fill this in. The z-score tells you that 10 is 2.5, let me use a different color, 2.5 standard deviations to the right, right? Because we are above the mean. So to the right of the mean. Okay, what is the mean? The mean is 5. Right? We are centered on 5. Okay. Next, suppose a person gained 3 pounds. Right? Remember that X is weight loss. Okay? So if you gain 3 pounds, that's the opposite of losing weight. So Z equals, so let's figure out what Z is. So if you gained 3 pounds, that means that your X, our little x, is going to be -3, right? So gained 3 pounds, so Z equals little x minus mu divided by sigma, right? What is mu and sigma? Okay, they told us the standard deviation is 2 and the mean is 5, right? So remember, x is a random variable that is distributed with mean 5, standard deviation 2. This is mu and this is sigma. All right, so Z equals -3 minus 5 divided by 2. All right, do what's in the top first. -3 minus 5 is -8 divided by 2, and this is -4. So what is Z? Z equals -4, which is, so that tells you, what does that tell you about X, right? If we were to draw out this distribution, in the center we have 5, -3 is down here, right? If we were to go 4 standard deviations below the mean, right? So basically 5 minus 4 standard deviations, so standard deviation is 2, so 5 minus 8 is -3. So we are 4 standard deviations, okay, below the mean. Below is to the left of the mean.